Welcome to MAKE, Hands-on Intro to Engineering Design, a course taught at the University of South Florida. This tutorial discusses creating animations by driving constraints, as well as creating video productions using Inventor Studio. Hi everyone, today we are going to be discussing animations in Autodesk Inventor. There are two ways to do animations, and I'm going to show you both of them. The first is to use the drive constraint option that's available in the general assembly environment, and this allows you to kind of do some quick animations, whereas the second method I'm going to show you uses the Inventor Studio, which is similar to 3D Studio Max, another product offered by Autodesk. And in there you can do some more advanced animations using cameras and zoom and transitions between different scenes. So it's basically a full-fledged animation studio, whereas the drive constraint that I'm going to show you initially is really just for some quick and dirty animations to show the capability of your assembly. So let's just get started working with these drive constraints. So if you can see here, I have a little sample assembly. It's really just a simple piston assembly similar to the rotary engine example that I've been using in some of the previous tutorials. And this one, you can see it's fully constrained. I can't move any of these parts, and we get the proper motion that we expect when moving the crankshaft here. So to get started, what we have to do is give ourselves a constraint that we actually want to drive. And so a lot of people think that, oh, you have this concentric constraint for here, you must want to drive this part. Well, in reality, that's not the case. What we need to do is apply an angle constraint, and we'll actually animate that angle. So what we're going to do is we're going to define an angle on this crankshaft piece here, and then we're going to move that angle. So what I'm going to do is go up here and click Define Constraint, and I'm going to use this flat edge on the crankshaft, and I'm going to use this edge here on the housing. I'm going to use this angle constraint and do this solution, the directed angle solution, and I'm going to give it a value of minus 30 degrees. Hit OK, and so now you can see our part has essentially been locked because we've predefined this angle here of this flat edge and the housing. So if we look from our top view, you can see can't move any of these parts. They're all fully constrained. Let's go back to our home view here. And what I'm going to do is just go here to the eccentric lobe. I'm going to right click. I'm going to open up the constraints here so you can see all of the different constraints that this part has applied to it. And we're going to select this angle constraint that we just created and click Drive. And what this is going to allow us to do is actually drive the constraint through various values. So it gives us a start, an end, and an end value. So what I'm going to do here is, since we start at minus 30 degrees, I want it to do one full rotation, so I'm going to select 330 degrees. Now if you notice, I've opened up some of these extra options down here in the bottom, and these just give you some control over how fast you want the part to move during the animation, as well as how long you want the recording if you're going to make a recording. So the two options I just mentioned, the increment here, this is how fast you want to, this is the increment from your start to your end value. So if you can think of this in terms of maybe programming, this is your increment of your for loop, say. So if we want, a rougher animation, because maybe it's not important to see all of the individual steps, we can increase this value, which would also increase the speed. But in this case, we want it to look very smooth, so we're going to select 1 degree as our value. You can also do total number of steps. So in our case, that would be 360 steps, because we have 360 degrees of total travel angle. But we're going to use an increment of 1 degree, and then we're going to increase our AVI rate to, say, 30. And that's going to be the rate. I'm not exactly sure what this value indicates, and the help is lacking for this section. But through my experiments using this, I've realized that when you increase the AVI rate, it actually decreases the length of your AVI that you will create using this function. So once we've changed these settings, 30 is about good for what we're trying to do here. So you can click the record button, and this will bring up a save as dialog, and I'm going to record it over the one I created when preparing for this this tutorial. So I'm just going to hit save. I'm going to replace that. It gives us some options here of how you want the final product to look, the final video file. So you can select some of the compression rate and then the actual size of the video. You can hit OK. And when we push this forward play button, it will actually start the recording. And so I'm going to click this button. As you can see, it's driving through all of the angles. Finishes up, the dialog comes back up. We can hit OK or cancel, either one. And that is going to finish our animation. So if I can bring up the folder that this is contained in, you can see we have our piston.wmv file. I'm going to double click on that just to show you how it looks. You can see we have our animation. So that's the first way that you can go about creating animations here in Inventor. And we use the drive constraint tool. Alright, so now that I've shown how to do some simple animations using the drive constraint in the assembly environment, I'm going to show you another more advanced way to make some better animations that you have a lot more control over in terms of what the parts are actually doing and how the final video product looks. So let's get started with that. We're going to go in and we're going to click the Environments tab up here in the ribbon. We're going to go click into Inventor Studio. So this will bring up the rendering ribbon, and this gives us all the different animation options. So you can see we have a different tree over here, and these have cameras as well as all your parts, including the constraints, which we will again animate in this environment. So the first thing we need to do is to activate the animation timeline. We'll get a little dialog, and we just want to say OK. That will allow us to use the animation timeline. So when we bring this up, it gives us a timeline as well as whatever parts we end up animating that will show up in this section on the left here. So what we want to do is first animate this constraint, and so we kind of do that in a similar manner to the way we did the drive constraint. We right click on the angle and click animate constraints. This brings up a similar dialog box as to the drive constraint, but with more options. So we can say the action here gives us a start and end as far as our degrees are concerned. So we're going to type in here, we want to say do 10 full revolutions in 30 seconds. So we can conveniently do the math in here. 360 times 10 minus 30 will give us what our final value we want to be, and then we're going to start here, say here in our time, we're going to specify the time, so we give it a start time and an end time, and it will calculate the duration. We're going to start it at 0 and end it at 30 seconds. Also, some options you have here are the acceleration, and so you can specify velocity versus time profile based on percentages. So I'm just going to leave it default here, but this says the first 20 seconds we're accelerating, first 20% we're accelerating, then for 60% of the time we're flat constant velocity, and then the last 20% we're decelerating. So I'm just going to leave all that constant and click OK. And now if you notice down here in our animation timeline, we now have two new little timeline features here for the angle constraint between the eccentric globe and the housing. So if we minimize this timeline, we go back and we play the animation, you can see on the screen there the constraint being driven and the piston moving as it should. And it will go for 30 seconds and use the animation or the velocity profile that we had selected in the animate constraint dialog. So all seems to be running. I'm just going to stop that and we'll go back to the beginning. Now if we wanted to, we could just click here, record animation if we're satisfied with this view. It gives us a lot of the exact same options that we had before, where we can select our file location, we can select the frame rate, the time range. These are all pretty self-explanatory settings, and it will allow us to render the image. I'm not going to do it now because it takes a little time, but we end up getting also a better quality image, a better quality video than if you were to just use the standard drive constraint animation as I did in the first part of this video. So I'm just going to close that, but now we could, if we wanted to, render this video from this view. But one of the cool things we can do with Inventor Studio is actually change the camera view to create a more dynamic video experience, something much more like an actual produced video. And the way we do this is by creating various cameras and then creating transitions between the cameras and whatnot. So the way we can create different views and to incorporate these views into the video is by creating the cameras, as I mentioned. So what we can do is right click here on camera and we can create a camera from the view. So I like the view that we have now. That's our home view, and I'm just going to say create camera from view. Now you can see we have camera 1 here. It shows up on the screen. We're looking directly through the camera, so you can't actually see it, but if I move around here, you can see there's a camera and the target. And the camera indicates the orientation of where that view is, and the target is what it's actually looking at. And so I can right click here and I can say set view to camera, and it will actually bring me back to that view, so as if I'm looking through the camera. I can also create another view, another camera in the exact same manner. So say we want a top view. We want to get in a little bit closer. So we'll go like this, and we can again right click over here. We can create camera from view. If we wanted to maybe change that orientation just a little bit, we could move ourselves, say like this, for instance, find camera 2, and we could say set camera to view. It would adjust that camera for us. I'm going to go back to the top view that we had previously, and I'm just going to right click camera 2, and I'm going to say set camera to view. So I like the top view, and just so we can have a third, we'll put a side view here. We're going to create another camera from this view. So now we have 3 cameras, one from the home view, one from the top, and one from the side. And we can actually go through, and if we click the cameras down here on the animation timeline, it will put those cameras, or it'll put our view to that camera. Another option we have with these cameras is to actually animate the cameras themselves. And so what we can do is in the animation timeline, we can say for camera 1, we can click the little camera icon, add camera action, and it will open up a camera action here in the animation timeline. I can double click on that action and we'll bring it up. And one of the things that people like to do often is to create a turnable camera, so this will rotate us around the part so we can get in the video a nice view of everything. So what I'm going to do is I'm going to click turnable, click this action to turnable, and we're going to say we're going to use the orientation, the axis of our part. So if I can see that, we want to rotate around the y-axis here. So we select here Y origin, Y origin, and that actually gives us a little indicator on the part. And then we can select our revolution criteria. So I'm going to say, we want 3 revolutions. We're going to specify the time here, and we're just going to have this thing do 3 revolutions over 30 seconds. Or I'm sorry, it's going to do 3 revolutions per minute over 30 seconds, so it'll rotate 1.5 times. So now if we want to see what the animation looks like through the view of camera 1, we can go back here, we can select camera 1, we'll minimize this, and then we'll just hit play. And so as you can see, our camera is moving according to the time, as well as the animation that we created. I'm just going to stop that. You can again go through camera 2 and camera 3, and it will show you, by selecting this camera option down here, it will show you the view at that point in time on your animation timeline, what the view from that camera looks like. So since we've only animated camera 1, the only one that's going to change over time is camera 1. So as you can see, as we move this around, the camera itself moves. So if we would like to actually combine some of these different cameras, because if we were to render now, it will only render according to the view that we select, or when we click the render, it will ask us, it'll give us an option of which camera we want to use. Say if we want to use several cameras, we then have to activate the video producer timeline. So the way we can do that is we go up here to video producer. We can click on that. It's another dialog. We have to activate it, so we say OK. And this will bring up a similar animation timeline, but it's a single timeline. So the way that we can then create a nice video is by using our 3 cameras here and creating some combination of camera views to create a final video. So what you can do is drag and drop the different camera views on here and then adjust the times accordingly. So I actually didn't want to put camera 2 there. We'll start off with camera 1. And if you double click on it, it gives you some options of when you want to start. Asks you which animations you want to use, as well as which camera you want to use. So we're going to say, since it's camera 1, we want this to run for, say, 10 seconds. We can then put camera 2 in as our second shot, and we'll double click this and say we want it to run for 5 seconds. So it goes from 10 to 15. And then camera 3, 2 seconds is fine for camera 3, and then we'll put camera 1 back in here for the remainder of the time. So we'll say this ends at 30. So if we want, then we can go and we can actually watch this video with the cameras. This just gives us a preview. So as we can see, it does camera 1 for 10 seconds, switches to camera 2. This will go for 5 seconds, then camera 3. And now we're back onto camera 1. And this will go for 30 seconds. I'm just going to stop it though. So another cool feature of this, again, you could just click the render button and it pops up the exact same rendering dialog as it does for the animation timeline. I'm just going to close that real quick because there's a few more things I want to show you. I bring up again the video producer toolbox, and you can go in here and add some transitions to make a much more professional looking video. So we can add a fade transition that we could put in between these. And I'm going to shorten up these videos now that we're going to put the transition. So I'm going to say this only 8 seconds. This transition, we want it to be a 4-second transition. So we've now added the transitions in there. We could add some more if we wanted. Again, it extended the length a little, so I'm just going to shorten this if we want a 30-second video. You just have to be mindful that once you insert a new piece of video or a transition or whatnot, it's going to increase the total length of your video. One thing to note is that the transitions, the fade or wipe or whatnot, will not show up until you have rendered the video. So when we watch the video, we're just going to see, if we preview it here in Inventor, we won't actually see a smooth transition, which would normally start at 8 seconds, which would be now. You'll just see a quick transition. So just note that when you do render the animation, you will get a nice fade or whatever transition you are looking for. It just doesn't show up in the preview. So that is all for the animation videos. I hope you enjoyed them. Thank you. This concludes our tutorial. Thanks for watching.